Hi, this is video 1 of 3 going over our last unit exam on solutions. So we are going to revisit the skills necessary to be successful on this unit. Here we go. First and foremost, this gentleman, Mark Rosengarten, fantastic information. You can find it on YouTube. This here is a song I played many times in class that goes over many of the skills related to this unit. So please take a moment and, well, here's the URL. Let me move it to where you can actually read it. Let me get this out of the way. There it is. All right, so please take a moment. Watch it. Watch it a lot. Question 1. At standard pressure, what substance becomes less soluble in water as temperature increases from 10 degrees Celsius to 80 degrees Celsius? First of all, let's recognize that we are talking about standard pressure. Standard pressure, as it states right here, standard pressure. Here on our reference table, we have standard temperature and pressure, and standard pressure could either be 101.3 kilopascal or 1 atmosphere. They are the same thing, just different units, just like 500 pennies is $1. Okay, so now that we identified what that is about, let's take a look at the problem. It is saying, I got to move this over. Once again, less soluble as the temperature goes from 10 degrees Celsius to 80 degrees Celsius. And we are talking about HCl, KCl, NaCl, and NH4Cl. That's hydrogen chloride, and if it's in water, it's hydrochloric acid, potassium chloride, sodium chloride, and ammonium chloride. Let's identify these lines. We're working between 10 degrees Celsius all the way to 80. And HCl, where are you? HCl. There we go. Let me change the color of the line. HCl is right here. So we're talking about this line. KCl is right here, so we are talking about this line. Forgive me that I'm off the line a little bit. NaCl, this line. And ammonium chloride, this line. So between 10 degrees and 80 degrees, which one is changing the least? Okay, so for HCl, it is going from right there, which is 80 grams, all the way to right over here, roughly 50. Again, at standard pressure, which substance becomes less soluble in water? Oh, you know what? I should just stop there. Which one is becoming less? Going from 80 down to 50? All right, I'm done. It's choice 1. All the other 3 lines are increasing as you go from 10 degrees to 80. Number 2. Which compound becomes less soluble in water as the temperature of the solution increases? In all honesty, same question, just mildly different words. It's asking, as you increase temperature, which one is less soluble? So which one of these, as you increase the temperature, the line decreases? So is it HCl, KCl? Wait. This is the same question, same choices. We've got to choose number 1 once again. But be cautious. Other questions might ask you which one increases solubility. Number 3, which compound is insoluble in water? So not soluble in water. For that, we do have some reference tables that can assist us. We have this table F, which is all about solubility. Solubility guides, it reads, solubility guides for aqueous solutions. And we have all these different conditions, namely, all of these substances, all of these ions will be soluble if you see them, unless they are in combination with these other ions, and then it would flip the meaning. This side, all of these ions are insoluble, unless these exceptions are met. So let's see what we have. Shrink this and take a look. This is KOH. KOH. As discussed in the past, if you see 3 elements in a compound, you must be suspicious that there's a polyatomic ion present. Now, is there? Here's where table E would assist us. When you inspect, here's OH. This OH is right here. So what's going to happen to this substance? It's going to split into ions of potassium and hydroxide. Now, will this substance be soluble? Let's inspect here. Do we see potassium or hydroxide located in this? Well, we do. I see hydroxide right here, which means that hydroxides are insoluble unless, let's see what the exceptions are, unless they are in combination with group 1 elements, calcium ions, barium ions or strontium ions, or even ammonium ions. Now, do we have any of those in potassium? Well, take a look. You've got to know a little bit more about potassium. It said group 1 ions. And is potassium group 1? Right here is group 1. Right there is calcium. It is a group 1 ion. Get this out of the way. Bring this back. So, is it soluble or insoluble? It would have been insoluble, but because we do have potassium, it is soluble. Can we choose number 1? Which compound is insoluble? Nope, that's soluble. How about ammonium chloride? Ammonium chloride. Do you see ammonium anywhere on this? Ammonium, there it is. Ammonium. Ammonium is soluble. Are there any exceptions? No exceptions. So, ammonium chloride, soluble. Again, we're looking for insoluble. Can't be. Okay, sodium phosphate. Sodium phosphate. We could either look for sodiums, and sodium is a group 1, or we could look for phosphate. And you'll see both. Right here it says all group 1s. All group 1s are soluble, no matter what. Over, where's ammonium? Oh, even right here. All are soluble. No matter what, it's soluble. Let's get rid of it. Now, just for completeness sake, let's do potassium sulfate. I'm sorry, lead sulfate. It splits right there. Lead sulfate. And where are the sulfates? There they are. Can't hide. Sulfate. Now, it's soluble unless it's with any of these other ions, and there it is, Pb. There's the one that is insoluble. Choice 4. All right, this question is no different. It says, according to Table F, which compound is soluble in water? And here, instead of seeing the elemental symbols, the formula, as you may, it's actually just spelling it out for you. So let's just jump right into it. All right, barium phosphate. Do we see phosphate anywhere? Where are you, phosphate? There are the phosphates. All right, now, is it soluble or insoluble? Well, it is insoluble unless it's combined with group 1 elements. Is barium group 1? Where are you, barium? There it is. Is that group 1? Nope, not in the least. So, barium phosphate. Barium phosphate. It's going to be insoluble. Is that what the question's looking for? Nope, it wants soluble. Number 1 is out. Calcium sulfate. Now, before we go anywhere, where is calcium? Okay, calcium's a group 2. There she is. Okay, so calcium sulfate. Let's look at the sulfates. We're looking for soluble ones. Sulfate, sulfate, sulfate. Where are you? There it is. Sulfate. It is soluble unless it is with calcium. Wait. Unless it's with calcium? Unless it's with calcium? So, soluble. Nope. Not soluble. Get rid of it. Next one. Looking at silver iodide. 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 There's iodide. Okay, the ion of iodine. They are soluble unless they're with these other ions. And do we have a match? It's saying silver. And silver is Ag. We found ourselves a match. The answer is 3. All right, next. The solubility of potassium chloride, solid, that is extremely important here, in water depends on, well, let me remove the cover here, then pause, and you decide for yourself. Now pause it. All right. The solubility in water of solids and liquids or gases, this could be important later, but in solids and liquids, not affected by pressure, but increases when temperature rises. Which choice? Pressure on the solution? No, pressure does not affect solids. They're not compressible. Rate of stirring? Okay, that just means it will get there faster, but it doesn't change how much it's soluble. Now the size of that? No, it just means that it will get there sooner. But what can increase the amount that can dissolve? It is choice 4. Now last for this video is a very similar question. It says, under which condition of temperature and pressure is a gas most soluble in water? Just like the previous one, let's uncover this. Go ahead, pause, read it through, and let's discover the answer together. Okay, solubility in water. I am assuming you did pause it and read it. Gases. Increases when pressure is increased. Think about soda. If you want the bubbles to stay in soda, you will increase the pressure. All right, and that's also why after you uncap a soda bottle, you start losing the gas. All right, so increase when pressure is increased, or increases when the temperature is decreased. You want to put that soda in the refrigerator after you open it to keep the fizz. Which one of these match? High temperature? No. High temperature? No. Low temperature? Looking good. Low pressure? Nope. We want to increase the pressure. Choice 4.